pi d square over 4. I put that. And another mistake you do in exams, we give you, for example, an area in centimeter square, and you want to calculate j. You forget to what? To convert to meter square. Those are mistakes to avoid in exams, because based on my experience, many years experience, I'm seeing students doing these mistakes in the exams. Those are silly mistakes, but you lose at 1 point in a multiple choice. You have this file, Shabab. These files they exist. This file you have it in classwork. It is called revision exam 2. Go right now and open your computer. You will see it. You can download it. You can print it. Okay, like this. Okay, so in chapter 26 we define the density of the current, we define the current, and we define Ohm's law. Ohm's law, it is that V is equal Ri. And we said that current and voltage in a circuit are proportional to each other. And that constant of proportionality is called resistance. It's a device that controls the current in a circuit. والله يا شباب. That's what does a resistor. It controls current in a circuit. Resistor is in ohm, and Ohm's law tells me that delta V is equal Ri. Also, it tells me that this J that I defined, the current density, it is proportional to the electric field established on that circuit in the battery. And is equal to sigma E, with sigma called a constant called conductivity. 1 over sigma is called resistivity. I can also use. I can say sigma, or I can say 1 over rho. So I can say E over rho, or I can say sigma multiplied by E. It is the same thing. This is equal J. And also, by the way, this is also Ohm's law. Mr. Ohm started with that, by the way. He started with J is equal to sigma E. That's the starting of Ohm's law. And then from there, we went to delta V is equal Ri. With R being or R depending on the geometry. R is equal rho L over A, with rho resistivity, and L the length, A the area. So the more area I have, the smaller is the resistor. The longer I have, the bigger is the resistor from this relationship. Well, let me tell you something. Chapter number 26, there is no problem on it. There are only two very easy questions. All of you should not miss them. If you miss them, believe me, you are not even worth being at the university, because they are like high school or mid school. Like calculating R, for example. Who cannot calculate R? Like calculating power for the R. And the power for the R is what is again? This is also a third form of Ohm's law. ولا شباب. Ohm's law also tells you that the power is equal I delta V, which is equal I square R, which is equal delta V square over R, depending what you have. If I give you this two, delta V and R, you do this one. If I give you R and I, you do this one. If I give you delta V and I, you do this one. Right, Shabab? So Ohm's law, it's three relationship. Number one, delta V is equal IR. Number two, P is equal this one. P is equal I delta V, I square R, delta V square. This is number two. And number three is this one. J is equal sigma E or E over rho. All these three relationships are called Ohm's law. They are the most important thing in this chapter. Okay? Again, we have learned that a resistor is a device that will change the amount of it will change because of temperature. Why? Well, it is found to be like that. It behaves like R is equal R01 plus alpha. Why? Because rho, it's rho that changes. Actually, it's rho that changes. And in general, rho, R, the shape of R, like the area and the length, change very low, less than 1%. So we neglect that. It's rho that changes when the temperature changes. That's why R also does do the same change, which is R is equal R at a certain temperature, 1 plus alpha, that's a property should be given to you. It characterizes your material, and T minus 0, this is the final, and this is T that you know, or T reference if you want. Okay, this is chapter 6. It's the easiest chapter. 2 questions only, multiple choice, and no one can miss it. If you miss it, you don't deserve to be an engineer. They are very easy. Okay, now let's go to chapter 27. Chapter 27, Shabab, it's a continuity of electricity, but this time we defined how we deal with resistors if they are in series or if they are in parallel, or if they are not series and they are not parallel, because there are three cases: either series or parallel, or not this one, not the other one. This is possible. But in order شباب to study that, let me remind you that when you take a battery, the battery is the reason for which you have a current in the circuit. Right? It's the battery that moves the electrons. That's why we call it EMF, electromotive force. People at the beginning call it like a force. Why? Because they saw when they put the battery, charges move. So it is the reason. It's like a force. Because we know that things move because of a force. That's why they call it EMF. But EMF actually it's the voltage. Remember that. It is potential difference, electric potential difference. It's a voltage, delta V. Well, any battery that we use has a perfect delta V, has the ideal, the one that should be with like the 3 volt, the 12 volt, and so on. But in reality, any battery has already inside it some kind of resistance because it is made of material, and all material have resistance. So the battery, before even giving this current, before even giving this power or energy in it, it will lose some of it because of the small r. And that's why now we represent the battery with the perfect EMF, E, and with a small battery R. That's what we do. Now, when we put a big battery R, we call it a load battery, a battery that we want to use. Sorry, a load resistor, not a battery. If you put a load resistor R, then you should agree with me that I should be equal E over R plus R. Well, that you could know that when two resistors are in series, we add them. Remember that. So two series, we add them. So it is E, the total voltage, over the total R, which is R plus capital R. Well, Ohm's law is telling me that I is equal to delta V over R, so it's equal to E plus R plus R. So this is the first thing I need to know from chapter 27, that any battery could have a resistor. If it has a resistor, the voltage across the battery will not be the EMF E, but it will be what we call the terminal voltage, delta V, which is equal E minus IR, which is equal also E Q equivalent. Okay? This is the first thing I should know in chapter 27. Then we have seen what is the situation that resistors are in series. If resistors they are in series, how we deal with them? R total is equal what?
We just add all of them
It's
together.
just the sum. It is just the sum. Forget the capacitors. Be careful.
It's
Different.
opposite of capacitors.
Now we forget the capacitors. Okay? Yes.
Is it E minus or plus?
What is the minus plus? What?
Resistors actually
What are the numbers? Everything is clear here. Everything is clear here. Delta V is equal to E minus IR. Delta V is equal to E minus IR. And everything is clear. What is the question? I don't understand. It's clear, right? What is your question? I don't understand.
It was minus or plus?
Which is minus of plus? What is minus? What? Well, they are here, the formula. They are clear to you. It is minus. E minus IR. Why minus IR? Because your current goes from the negative to the positive outside. So when you go like this, it's a minus. You are in the direction of the current. When you move, well, it depends how you move. But here, in general, we move in the direction of the current. So it's a minus IR. Okay, my dear. So resistors in series the sum of them or the equivalent will be sum, right? And resistors in parallel, stop talking please. Resistors in parallel, do this. R equivalent parallel, do the 1 over, sum the 1 over, but please make it power minus 1. Do not forget that. If there are two only, just use this good. This is the good one. If there are two only, use product over sum. This is for the parallel. So the parallel of the two resistors is smaller than any of them. And the series, the R series, is bigger than any of them, right? Because it's sum. So remember this. Now, how do I know they are series or they are parallel? Well, we said that last time. Parallel means same voltage, right? Series means what? Same current. Same current, series. Same voltage, parallel. There are situations that are not parallel, are not series. Well, in this situation, thanks to Mr. Kirchhoff, he told us you can use two easy rules called the Kirchhoff rules. The rule of the junction and the rule of the loops. Well, they are based on what? The rule of the junction, it is based on the conservation of charge. What comes in goes out. If 20 students are coming to my class, at the end of the class, only 20 students can go out. We don't create students. We don't nail them. Okay. And charge means current. ولا يا شباب؟ Because it's only a ratio. So, which means sum of the current is equal to 0. Well, another way to look at it is the current coming in, I make it positive like I3 here. Going out like the I2, I make it negative. I1 positive. So I can tell that sum of the current entering should be equal to sum of the current exiting. But this means what? Means the one entering with the plus, the one exiting with the minus, the sum of them should be 0. That's the same. A equal B, A minus B is equal to 0. Same thing. Okay, Jabab? And the other rule is the loop rule. The loop rule is based on the conservation of energy. And we have seen already in chapter 24 that delta V is equal to the integral of E delta L. And we have seen that delta V is equal VB minus VA. If V becomes A, same point, VA minus VA in mathematics is 0. ولا شباب. So VA minus VA is 0, which means if I come back to the same point in the loop or in the circuit, my delta V should be 0. This is exactly the meaning. So while you do a loop, you could enter in a resistor in the direction of the current. If you do so, you would say it is minus IR. ولا شباب. While you're doing it, if your current is opposite, you come like this, and the current is opposite to you, you will say plus IR. When you enter the battery by the positive side, what do you say? You say minus. When you enter in your direction by the negative side, you say plus. We'll do an example of this, of course. It's very important. Now, chapter 27, well, maybe 2 questions, but for sure one problem. What problem? Very easy one, Kirchhoff rules. We will ask you, find the current I1, I2, and I3. We'll do an example, inshallah.
2 multiple choice questions and 1 problem.
Yes. So this is the first part, Shabab. The first part, I'm preparing you the first part, which is electricity. Believe me, Shabab, this part is the easiest by far. This is where all students get almost 100% in the grades. You don't miss them. The one who misses them, he should not be in this class. Believe me, you should not miss them. They are really easy. We will do the Kirchhoff, inshallah, example afterwards. Let me continue with my formula, with my summary of chapters. So we said we have 4 chapters. 2 we did, alhamdulillah. That's what's time now. It's very good, 15 minutes, very good. Let's do the 2 others. The 2 others are pure magnetism. Wala shabab. Chapter 28.
We still didn't do the charging and discharging.
Oh yeah, I forgot that there's one more part. There's one more part about chapter 27. Chapter 27 also we deal with how do we charge a capacitor or we discharge it. Well, a capacitor will play a role of a battery, right? And battery, as you know, you battery your phone, you charge it all the time, and it discharges. You charge it and it discharges. Well, what you need to know when you come to the exam is in the process of charging, what is Q of T? And we give you this formula in the first page. We give you the formula. But you need to know how to use it. Like Q max is equal to 1 minus exponential minus C over tau. This is when R and C are in series. Well, with tau called the time constant, which is equal to RC, what characterizes tau? Tau, as I told you last time, 5 taus makes the lifetime of charging. 5 taus will be 99.9 of charging. Like 5 taus will be also the discharge, the time of discharge. Okay? You need to know that Q max is equal to CE. Why? Because Q max, chapter 25, it is equal to delta V max multiplied by C. C is a constant. It depends only on your capacitor, on your battery. So C is C. We don't change it. But V, we can make it max. What's the maximum voltage I can get from another battery? What is the EMF? So it's EC. That's the maximum charge. Q max is equal to CE. And you want the current, you make just a derivative. If you make a derivative of that function, it will be I max exponential minus C over 2. What is I max? Remember, the I max is at the beginning. Remember? At the beginning, my class is free. I can come and fill all the chairs of the class. So the current can be maximum. The number of students that fills an empty room will be easy. While if you are in a highway, and you are the only one in the highway, you can go any speed you want. Nobody will stop you, right? You are free. All cars can come in a free highway. But if the highway is stuck, if the highway that a lot of traffic, you cannot move even if you have a Lamborghini. You can do nothing. You cannot even go 20 kilometers per hour. So this is the idea. So at t equals 0, I is max. If I is max, it's like the capacitor is not there. It's like short. So it's like only a resistor. And if only resistor is there, the current should be E over R, Ohm's law. At the end, when it's all done, when all the charges are on the plates, these charges will not allow other electrons to come. This is hayat. We call this scaling effect. If my class is full of students, can I accept one more student? I cannot. That's the same idea. After the battery is fully charged, current is not there anymore. It cannot exist. So I will be zero. No DC current. Now I can use that battery. I take the old battery. I can use my capacitor as a battery. If I put it, the current will be reversed, right? Because instead of taking the current, it will give current now. And that's why there is a minus sign on the current here. But I don't want you to worry much about this. You can take it. It's only a direction. You care about magnitude. Okay, Shabab? So magnitude, you take this minus. So a current will exist, which is will equal Qi over RT, exponential minus T over tau. You know what is tau? You know what is Qi? Qi is the maximum charge, which is what? Which is EC. Right? That's the maximum charge. Qi is the maximum charge, which is EC. And of course, the charge here will decrease because I'm consuming it. استعملها. So it will decrease. I have a good battery 100%. After 1 or 2 hours, it will be 70, 40%. Okay? The question that we ask in this part, and there is a question, by the way. There is a question here. So we have 2 questions on chapter 27. One about maybe series, parallel, R equivalent, which are easy, by the way, very easy. You don't have a right to miss it. Again, believe me, the question in the exam about 27 is a question that no student in engineering should miss. Then there is another question for sure. The type of question I told you when I covered chapter 27, the type of question, for example, find time for which the charge is 1/3, for example. Or find time for which I lose 30% of my energy. What does it mean, Shabab? If I say I lose 30%, so my energy, I have to consider 70%. Read carefully your questions. And then set your equation and solve for T. It's not a big deal. Right, Shabab? It's not a really big deal. Well, the same thing we did for charging will happen with the charge. Same story, just different formula. And the formula are in page 1. You have them. The formula are there. So again, Shabab, you don't have any reason to miss these 2 questions. I mean, about 4 questions in chapter 26 and 27. Four multiple choice, 4 multiple choice, and 1 problem about Kirchhoff, which we will solve an example for it. If not today, we will do it today. We have fun. We'll do it today, inshallah. Okay? We'll start it today. And we continue on Sunday or the revision, inshallah. Okay, Shabab? Okay, now chapter 27, the pure magnetism. In the magnetism, we dealt with 2 chapters. Chapter number 1, we only learned how we calculate the magnetic force. That's this chapter, 28. We just learned, تعلمنا how to calculate the magnetic force in 2 situations. Well, a magnetic force, Shabab, exists why? A magnetic force exists if a charge is moving, number 1. If a charge is moving, if a charge is not moving, do I have a force? Do I have a force? Everybody, no. Well, a charge that is not moving is called stationary. كلمة stationary معناها not moving.
Zero.
يعني V equals 0. Stationary يعني ما فيش حركة. Okay? So a stationary charge cannot have a force. No force on it. Okay, Shabab? And if now it is moving, there is a force. What is that force? Well, that force is a cross product of V and V, which means what? It is perpendicular to V and it is perpendicular to V. Now I need to use my right hand rule. So I'll open my palm of my hand rule and I put it in the direction of V. V, I don't know what it is, V. V, whatever, look for V. V like this, I go like this. Then I should kind of close a little bit my fingers, curve them, so that to go to the direction of which one? Of V. If V is this way, my stamp will be in my direction. If V the other way, my stamp I should be opposite. You know, right hand rule. Use right hand rule. Okay. So if Q is negative, FP automatically will be in the opposite direction. And you can get the components. If you know the components of V and B, you can get the component of Q by using the determinant method, which we have seen in Physics 191. Those are easy questions about it. Now, one important thing other than calculating the force is to know the trajectory of the particle if it goes perpendicular to B. If a particle goes in a place where there is a field in a plane perpendicular, it means V is always perpendicular. right, شباب? Like this. Whatever it is, direction in the plane, it is perpendicular to V. In this situation, I should move moving where? قولوا لي شباب. In what direct trajectory I should move it? In a circle. In a circle. Trajectory is a circle. If I say a circle, well, I need to know R. Properties of a circle. I need to know R, I need to know V also. V is given to me, by the way. V is given. Well, maybe I need to know omega. I need to know D, because it's a circle. If it's a circle, well, R is equal mv over qb. How did I get this? This one, Shabab, if it is a problem, you should do this. You should say fb, which is in this situation just qvb. Why? Because it is sine 90 degree. فهمت عليا؟ مش قلنا perpendicular؟ So it's just QVB. This QVB, following in Newton's second law of motion, should be equal ma centripetal. ولا يا جماعة؟ And from physics 1, I know what is a centripetal. ولا يا جماعة؟ This square over R. This gives me my R, which is that one. MV Now, if it is a multiple choice, you can use the formula R is equal mv over qb. No big deal. And you put the numbers. And if it is a problem, you should show me this. fb is equal qvb, which is equal mac, which is equal m squared. Then you see these two steps, you should show them if it's a problem. So we might give you a problem about this. It's like, remember the problem number 2 in exam number 1? Most of you lost, like, lost 2 points. Why? Because it didn't show the steps of your work. Shabab, in problems, it's a mandatory, lazim, must. You have to show the steps of your work. You cannot put for me a formula and use it. No way. Show all the steps. So this is what you should do if problem. If a problem, you should write me these 2 steps. If it's question, you use it like this. Well, this automatically means what? This automatically means you can divide the t, because the t, we know what is the t. The t is just 2 pi r over what? Over v. ولا يا جماعة? I can also calculate it to be 2 pi m over v. I can get an omega if you want. What is omega? Omega is just v over r. I can get a formula for it. Omega is a v over is a qv over m. Now, if I put this in a velocity selector is a device that a charged particle is moving in a situation where there is a magnetic force pushing this way and electric force pushing the other way. So it is subject to what we call the Lorentz force. The Lorentz force is QE plus QVB. In this situation, for the velocity selector, V should be equal E over B. If V is equal E over B, it will go straight. Otherwise, it will move right or left. This is the selective. And so in this situation, the V will be equal to kinetic energy over M, of course, in general. And one important thing, if I have a charge that is not moving and I want to move it, what shall I do? Well, I put it in a voltage. I put it in a parallel plate. And we know if I put it in a voltage, then Q delta V should be equal half of mV final square. V final square. So this will give me the V. Sometimes will give you a charge. If a charge Q equals 0, and I want to have V final different from 0. What shall I do? I put it in a parallel plate so that Q delta V should be equal delta K, which is K final, because Ki is equal 0 always. I start from rest, right? Which is equal half of m V final square. So this will allow me, this allows me to get my V final, right? So sometimes you don't know V final. You have to calculate it first, right, Shabab? Then you use it. So this is, you can take a picture of that, it's very important. Okay? And although we have learned in this chapter 28, in a case I have a current, because a current is a moving charge, right, Shabab? A current is a moving charge. Well, the formula will be just IL cross B. If L is straight, is IL over B. If it's curved, I have to go FB is equal the integral. I is a constant. Just it will be delta L cross B. But in general, we don't do that. In general, we give you state wire. Okay. Finally, we have defined in this chapter the moment. We have defined in this chapter the magnetic moment, and we said that the magnetic moment of a loop. We have defined the magnetic moment of a loop, defined as mu is equal the current on the loop multiplied by its area, the vector area. It's a vector mu. Okay. And we said that therefore, if a loop, we put a loop in a magnetic field in a region where there's a magnetic field, it will feel a torque. This torque is equal to mu cross B, which means magnitude is a mu B sine theta. Theta being the angle between mu and B. And by doing this rotation, an energy will be involved. We can calculate this energy. It is a potential energy. It is equal minus mu dot B or minus mu B cosine theta. Okay, this is what you should know about chapter 28. Chapter 29. For that, let me make a pause. We take the attendance and we continue. I will count you, shabab, so make sure that you take your attendance for yourself only.
Someone went to the bathroom.
We are 30 here in the classroom. I want to see 30. As I told you, shabab, after the exam.
Sorry, you opened it in the wrong section. Wrong section.
So you open
Well,
the
why?
wrong section, yeah.
لا مش مشكلة.
0 out of 55.
It's just not a big deal. I will go and just.
لا ما حد دخل.
Is it today? Yeah?
ايوه
10. Yeah, I'll just delete it. لا حول ولا قوة إلا بالله. Pay attention, yes. But, 10 minutes after 6 because there is Salat al-Maghrib at 6, so it will start at 6:10. Okay, I will make the note. You will start at 6:10. You have 1 hour and a half. And so next week you have exam and you have quiz. On Thursday, like today, next Thursday, there is a quiz on these two chapters, the last two chapters that we are talking about, 29 and 28, plus number 30. Okay, let me see. Do we have 31? Good. That's good.
28 29 داخل في النت الشات لما
Let's continue, Shabab. So, now let's go to chapter 29. Wait, chapter 27, there is a problem on it, by the way. I forgot to tell you. So, chapter 27, maybe a question or two, but there is a problem. There is a problem on chapter 28.
1 or 2 multiple choice and 1 problem maybe.
Excuse me? Hello? Yes? Yes? 11, all 11. Yeah, thank you. Okay, so this is the last chapter for the exam, okay, but not last chapter for the quiz. This is the last chapter. So let me tell you again the format of the exam. Let's be fair. 7 questions and 2-3 problems. 26 there is no problem. Only 2 questions, very easy questions. 27 there is a problem. Keep sure, we will do it. And maybe 2 questions, easy ones. One about charging for sure, and another one. Number 28, there is a problem. I'm not going to tell you what problem it is, but there is a problem. What could be a problem? A problem could be about the torque, about the energy of a magnetic moment, or it could be about circular motion in a magnetic field perpendicular. That's what it will be.
Circular motion, vector
Yeah.
velocity or something.
Two things. And also there are questions, regular questions on how to calculate magnetic field in the case of charged particle or in the case of current with a wire, a thick wire. But this is easy. We have done that. Now go to chapter 29. Chapter 29, Shabab, two things are important. If you want to summarize it, two things are important, which are two laws. The law of Buan-Savart, and this is number one. Then the law of Ampere law. Two things are important in chapter 29. The Buan-Savart law and the Ampere law. The Buan-Savart law, Shabab, two things you need to know. Number one, you need to know how to calculate a magnetic field due to a small element of current I in a wire, ds. Small element ds in current, having a current I in the wire here, like I'm showing it to you here. Well, the law of Buan-Savart is a law that involves cross product. It's complicated. It is telling you that if there's a current I moving in a direction ds on a wire like this one, then it will create at any point of the space, let's say that's my point P on the top, it will create a magnetic field that goes with this relationship. So it is perpendicular to ds, which is in the direction of the current. It is perpendicular to r. What is r? R is the vector that starts. That's very, very important, Shabab. If I have my curved one like this, two things I need to know, Shabab. Number one, if this is my current I, so ds should be like this. That's my ds. To start with, that's my ds. Now, depending where I am in space, well, if I am, let's say I am here. My point is here. Well, I can give you another point. If I am here, P prime, 2 points, two situations. Well, depending on where I am, I will define the R. I will define the R, and I will define the vector delta R. ولا يا شباب؟ الفيكتور delta R اللي هو الفورمولا هناك delta R, it should be the vector. Sorry, the vector R, the R hat. It is this one. That's the R hat. Well, I would say this is R hat for P, and of course, if I go from ds to delta R like this, I can use the right hand rule. If I do this, so my magnetic field should be what? It should be. That's my delta D. Now, if I am down here, let me put it another place. That's not a good one. Let me put it here to make it easier. Let me put it here. If my P prime is here, my point P prime is here, forget this one, no need to do this one. Well, again, I should define the direction R. So the R should be from here to here, this one. That's my R. Like this one before was also my R. Well, maybe to make it R prime, maybe to be different. And look, the S is always like this. But what is the R? The vector R prime will be this one. This will be the R prime, the vector hat. You see, depending where you are in the space. Now, before I did ds to R, I was out. Now, ds and R, well, it is not a good example. It's not a good example because it's almost parallel. I don't want to do parallel. So I will do it here. P prime, I'll do it here. And R will be here. R prime. And which means my vector R, this situation, my vector R will be which one? Will be this one. That's my vector R prime. The vector R prime. Which means, now, look, DSR. Now, it is DSR like this, DSR. So, the magnetic field that is created on this point P should be whatever, should be inside. You got it? So this is the way I apply, I get the direction, this is the way I apply that formula. The Buan-Savart, very important. Now, this is general. Now, what we'll ask you in our problems? we'll make it easy in our problems. We'll ask you two situations. When the wire is straight or the wire is curved. ولا يا شباب؟ it's sitting here. B due to the wire that is straight, like this one. If I am at the distance A, what I mean by distance perpendicular, right? The distance means perpendicular. If I am at the distance A perpendicular, or I can call it R. Like the magnetic field will be tangent to the circle. Why? You do this rule. You do this rule. You put your thumb on the eye and you curve your right hand, your fingers, you curve them. It will give you the direction of B, and B will be tangent to the circle of radius A. Yani, you will do something like this. If you put a current I like this, a magnetic field will be created here, so that a B, for example, look at it. B should be like this. That's B. That's B. That's B. That's B. That's B. You see, it is tangent all the time. It is tangent all the time. For the same radius R or A. Well, same radius. Okay, Shabab? So this is the rule when I have a straight wire. A straight wire, I can use the formula mu0 is equal to mu0 I of 2 pi. Now, this I can use this formula only for multiple choice. If it is a problem, I have to show it. I have to start from delta B. I have to show it. If it's a problem, I need to show the steps. Now, if it's an arc, if it's an arc like this, an eye is like this. I have an arc. And if this arc, like this, for example, this arc, I can, for example, know the angle of the arc. That's theta. This could happen. I know theta, but theta in rad, be careful, theta should be in rad. In this situation, you can say that B is equal, there is a formula for it, B is equal mu0 I over 4 pi R multiplied by theta. We can use this formula. Here, B, you can say it is equal mu0 I over 2 pi R, because I said R here. If it's A, it's A. If it's R, it's R. But this one only in MCQ. For a problem, you should show it. You should show the steps. Should show the steps. We'll do a problem, don't worry. We'll do a problem with an arc. I will show you the steps. We'll do a problem with a straight and arc, we'll do the steps.
So for
that will be ready.
For the problem, we begin with Biot-Savart law.
Inshallah. Okay, my dear. So this is what you should know about these chapters. Of course, today you cannot do it all. So if we finish this already, we are very good. And on Sunday, what I will do on Sunday I will solve two problems. One problem about the Buan Savar for the curved and for the straight, and one problem for the Kirchhoff. So that will be ready for the exam, inshallah. Okay. The third problem is about, we said it's about chapter 28. I'm not solve a problem on that. Go look for the old exams. There are many good problems that you can solve. Okay. But I can tell you, if you follow my instructions, you'll be ready. Just solve the old exams. With my instructions, you'll be more than ready. Okay. Now, the last thing, Shabab, I want to mention here, it is this one here. The other important thing, Shabab, also is the situation where, by the way, for a circle, theta is equal to pi, then B will be equal to mu0 I over 2r. Again, for a circle, you can use this formula for multiple choice. You cannot use it for a problem. For multiple choice, you are welcome to use the formula. You can memorize, you can use, no big deal. But not for a problem. Now, the other part, Shabab, we have seen, if two wires are close to each other, and if there's a distance between them that is A, they will feel an attractive force or repulsive force, depending on the direction. If it is same direction, attractive. If it is opposite, repulsive. And the force per length is equal to mu0 I1, I2 over 2 pi A. This one you can memorize, no big deal, because we'll not ask you a problem about this. To be only multiple choice. This one. F over L is equal to mu 0 by 1 I2 over 2 by A, with A the distance between the two wires. This you can memorize. It will be also, by the way, on your formula sheet. The other the other important thing, Shabab, to conclude about chapter 29 is the ampere law. The ampere law is very important. Well, in general, we give a problem in ampere law, but I'm telling you, we are not this time. We are giving you answer. So get ready, okay? But in general, we could give, well, in the final exam, we can give a question about this, because this chapter will be in the final exam. The Ampere's law is very important, and it's also very simple. What it tells the Ampere's law? The Ampere's law, it tells if you move in a, usually you take a circle or rectangle. If you move in a circle or rectangle, a closed loop, the integral of B on that closed loop, which is just B multiplied by the length of that loop, like B to pi r in a circle, or if it is not a circle, you can just calculate it, should be equal mu 0 I thought. What do you mean by I thought? Well, if the loop is like this, I would see if a current is going out, I can take it positive. If the current is going in, I take it negative. And I sum the currents. We have seen that in the slides. It's not a big deal. Okay? And therefore, this will allow me to calculate, for example, solenoid, and will allow me to calculate toroid. And these two are important, by the way. And by the way, for the solenoid, we found just mu 0 and I, with n being the density of number of lines, yani the capital N over L. And a toroid is just a solenoid that we make it like a donut. We make it a circle. So it is the same formula. It is mu 0 n over I, with the n just equal n over L. Look, n over, what is L? L is 2 pi r, because the length will be the circumference. So it is n over 2 pi r, it is this n. You see the same formula almost. So from the solenoid, you can get the toroid if you forgot it. But I think while giving that these two formula in the formulation. Okay? This is what you should know, Shabab, about the 4 chapters. As I said, inshallah, we will solve two problems. One on the Kirchhoff rules, in which you have to calculate the different I's, and another one on Biot-Savart in a situation where you have curved or straight lines. I'll stop it here for a moment, okay? Did you take pictures? Can I erase this?
وقال هذا ممكن نجيب فن
So in the exam we will have 2 problems.
3 problems.
هذا لا هذا قال ما راح يجي عليه بروبلم انا ممكن هذا ما راح يجي عليه بروبلم ممكن هذا ما راح ممكن واحد او اثنين من هذا